Hi everyone, I'm Stanley and I'm going to be showing you my smart mailbox device for my ME100 final project. So I'm going to begin by going over a quick construction of the device. So we can see here we have a cardboard box representing the physical mailbox. And on top here on this breadboard we have the Huzzah32 microcontroller, which is connected to some modules inside of our mailbox. And inside the mailbox, we have this HC-SR04 ultrasonic distance sensor, which is included in our lab kit. And this measures the distance from the top of the mailbox to the bottom where the mail sits. And this distance can allow us to quantify the amount and presence of mail inside the mailbox. And when mail is detected, we have a camera in the back, the ESP32 camera, which takes a picture of the contents of the mailbox. Alright, so now I'm going to demonstrate the operation of the smart mailbox. So we start by performing a soft reset in the REPL to boot up the system. So now we can see that our device is running and our ultrasonic sensor is working and recording values of around 10.7 centimeters between the top and bottom of the mailbox, which indicates the mailbox is completely empty right now. And we're going to put in a single letter to simulate new mail entering the mailbox. So when this mail is detected, a few things happen. So we publish through MQTT to an Adafruit IO feed, and we're communicating the percent of the mailbox that has been filled up. So if we go to our Adafruit IO feed, we can see that there's a value of 8, which means that based on the distance measurement we recorded from the mail entering the mailbox is currently 8% full. And we also trigger the ESP32 camera located in the rear of the mailbox to take a photo of the contents of the interior. And this photo is sent to the user's email through an SMTP server. So if I check my email right now, you can see that we have indeed received a photo which shows the inside of the mailbox with the letter we just placed inside. And we can repeat this and add some additional mail and the same triggers will happen again. So let's try that right now. So let's put 3 additional pieces of mail inside the mailbox right now. And it has indeed triggered our device again. And now if we look at our Adafruit IO feed, we see a value of 22, which means that our mailbox is now 22% full with the 4 pieces of mail that we inserted in total. And if we check our email also, we can see an updated image of the contents of the mailbox after we inserted those 3 white envelopes. Let's take a look at the code used to program this device now. So on the left here we have MicroPython code for the Huzzah32 microcontroller. And this code is used to interface our Huzzah32 with the HC-SR04, as we can see here, and also initiates a serial connection with the ESP32 camera. And we have a function in this code which is triggered by mail arriving, which essentially publishes like how full the mailbox is, like this mailbox is 20% full, to the Adafruit IO feed through MQTT. And something I forgot to show in the demonstration is that we have an IFTTT applet subscribed to this Adafruit IO feed, which sends a notification to the user's phone when data arrives and is published by this function. And here is a moving average filter, which we use to kind of filter out the noise of the ultrasonic sensor. Essentially, we're taking the average value of the 10 most recent measurements from the ultrasonic sensor, which we program to sample at 10 Hertz. And when mail is detected, which is a decrease in the distances detected, then we call our function to publish the MQTT, and we also write something to the serial connection to the ESP32 camera. In this case, we just write the capital C letter for capture. And this all repeats in an infinite while loop. Now, the code for the ESP32 camera is sourced from Random Nerd Tutorials. It's like this online documentation. So most of this code for interfacing with this camera module is not something I wrote myself. But essentially, I modified this code, which basically connects to the OV2640 camera on the module, and it also creates an SMTP server for sending the email of the photo to the user you want it to send to, as you can see here. And essentially, the code sets up the camera and the Wi-Fi connection to the SMTP server. And something I added here is in this loop function, you can see that we're looking for an incoming serial communication from the Huzzah32. And when we receive it, in this case, the C we sent is interpreted as a 67 in a byte. And this essentially triggers the camera, which then takes the photo and sends it to the user's email. So essentially this Arduino code is it's just programming the ESP32 camera module to wait for a serial signal from the Huzzah32 and take a photo when triggered. Thank you for listening to my presentation, and happy holidays. Bye.